Good day. I'm going to show you how to prove the theorem that states that exterior angle is equals to interior opposite angles. So the question can say prove that angle A, which is this angle, is equals to angle BCD. Or they can say prove the theorem that states that angle A is equals to BCE, which is just the theorem that exterior angle is equals to interior opposite angle. So remember, exterior angle is equals to the interior angle but the opposite of it. So it's the opposite of the interior angle, right? So exterior angle is equals to interior opposite angle. So that's how we say it. And just before I continue, don't forget to like the video and please subscribe to my channel so that you can receive more of this kind of stuff. So first you're gonna say construct line OC. So we're gonna call OD. We're gonna construct line OD and line OB. And then from there we're gonna say let angle A be X. And this question is more likely to come out, by the way. So we're gonna call this X. And then after calling this X, we're going to use the theorem that states that angles at the center is twice angle at the circumference. So if this be X, then this has got to be 2X. So we found this. So of course, we will tell them that DOB is equals to 2X. Why? Because angles at the center, okay, here I wrote it wrong. Let angle A be equals to X. All right, so we're gonna say angles at the center is twice angle at the circumference. And then from there we're gonna tell them that okay, so we found out this is 2X, right? Now we need to find the outer angle. So we found out that this was 2X, so we need to find the outer angle. So how do we find the outer angle? Angles around the point always add up to 360. A complete circle is 360. So now for us to find the outer part, we're gonna say the outer part is gonna be equals to 360 minus 2X, right? So the only funny thing is that this is DOP, this angle, and the outer one is also DOP. So how do I differentiate it? I can call this O1 or O2, but what I'm gonna do is I'm gonna call the other one the reflex angle of it, right? So I'm gonna call this angle BOD reflex. I'm just gonna put reflex so that we can differentiate it. It's equals to 360 minus 2X, right? Then the reason is angles around the point. So what I would have done at first is I would have just said angle BOD reflex plus 2X is equals to 360, right? Because it's angles around a point. So angles around the point will be your reason because they add up to 360. And then from there, when you take this to the other side, so it means that BOD reflex is equals to 360 minus 2X. So we got this part as 360 minus 2X. And then from there, we'll use the same theorem again. Angles at the center is twice angles at the circumference. So it means this part is going to be half of that. The angle at the circumference is always smaller than the angle at the center, right? So this part will not be twice this, but rather half this, so that the angle at the center will be twice that. So it means we've got to divide this by 2, right? So it means that angle BCD, I'm referring to this angle, right? It's going to be equals to, okay, 2 times that is going to be equals to angle BOD reflex. Or I could have just written it as angle BOD reflex is equals to twice angle BCD, right? So this angle is twice that. So it means that angle BCD will be equals to 360 minus 2x divided by 2, because it's going to be half of that. So 360 minus 2x divided by 2 will just be 360 divided by 2 is 180, and then 2x divided by 2 is x. So this part will be 180 minus x, and we're almost done. Now we need to find the exterior angle. But if you notice, both these are adjacent angles on a straight line. So how do we find it? It just means this angle plus this angle is 180. So we're going to tell them that BCE, so I was looking for this part, this is BCE, I named it E. So BCE is going to be equals BCE plus 180 minus 2x, because that's what we found, right? So this plus 180 minus 2x, or let me put it in letters first. So BCE plus BCD. So I'm going to say BCE plus BCD is equals to 180. Why? Adjacent angles on a straight line. So you write that reason. I'm not going to write it. I assume that you know that. So this plus this is 180. So then it's going to be BCE plus 180 minus x is equals to 180. When we take things to the other side, it's going to be BCE is equals to 180 minus 180 plus x, and these two cancels out, so we'll be left with x. So it means BCE is equals to x. So if you look at this thing, we call this x, and BCE is also equals to x. So it means they're equal. We have actually proven a theory, because they say it proved that angle A is equals to BCE, and angle A is, we call it x. And using this theorem, what we did was we said this angle is twice this angle, and in turn we used this angle to find the outer angles, and both of them add up to 360. So it's 360 minus this. That's what we got. And then now this part is twice this, so we use this to get this, and then from there we realize that these two add up to 180. So hence we use adjacent angles on a straight line to get that, and we figured out it's also x. So this is x, this is also x. So we're done. It means that we can say therefore angle A is equals to angle BCE. Why are they equal? Because both are equals to x, and we're done. So if you like this video, please just give me a thumbs up and subscribe to this channel. Any questions you've got, comment below.